Okay, now look at this. That's how we say when I integrate x to the power n, dx, n is the function. Then when you integrate, you add one more. That means the function n plus 1, you add one more x divided by n plus 1 plus c, and this c come from plus 0. Okay, so what happens if let's say n is negative 1? That means if I want to integrate x to the power negative 1 according to this principle, then you will get x to the power negative 1 plus 1 is 0 divided by 0 plus c. Of course, this is definitely wrong, isn't it? Because you cannot have plus c. So how to integrate if let's say the power is negative n? Okay, so first of all, we look at this one first. Okay, if I differentiate this, okay, if I differentiate ln 5x minus 1, then ln I change to negative 1, isn't it? The bracket I change to negative 1, and then I differentiate the 5x, I get 5. Meaning, when I integrate 5x minus 1 negative 1 dx, actually you plus 1, you get 0, which is not acceptable. Therefore, you get ln 5x minus 1. And then usually for ln, we have to use modulus because ln this is 1 must be always positive. And then you must have the 5 here, which is just like just now, the x, you must always remember we must have this, the red color one. I mean, we can integrate. Okay, next we look at this. That means if this is the case, let's say I differentiate this ln 3 minus x squared. I differentiate, I change the ln, I get negative 1. Okay, negative 1. And then I differentiate this, I get negative 2x. Isn't it? The negative 2x comes from differentiating this. So that means if I integrate this with this, if I integrate this, negative 1 with negative 2x here, then I get this ln. And then here also must be modulus. This one also must be modulus. Okay, then plus c. Okay, next come to this. What happens if let's say I differentiate this? Okay, the bracket, look at the bracket, ln become negative 1, same bracket. Okay, then I differentiate the bracket, I get 2 cos 2x positive. So that means when I integrate this, that means I have to integrate this one comes from here, therefore I must have this. Okay, then only I can integrate the negative 1 to become ln. Okay, to become ln and then plus c. Okay, so that's how you integrate the power with negative 1. So from here we come back to this, you see. So if negative 1 like that, so you see, if you integrate negative 1, you get ln. Okay, usually we have a modulus there. Okay, so now you see, I want to integrate this. So if I want to integrate this one can be written as 3x plus 2 negative 1. So if I want to integrate this negative 1, I will get a ln, isn't it? Cannot be 0 over 0. So what is missing here? I must have a 3 here. So what I do, I add a 3, I divide by 3. Okay, so therefore with the 3, now this negative 1 can be changed to ln. So that's why I get 1 over 3 ln modulus 3x plus 2 plus c. Okay, so that's how we integrate. So I can write it like this. That's how we integrate. Okay, and then furthermore we have one we have some more example here. Okay, let's see. I have this 2x squared over 4 minus x cubed. So what we do here, first of all, these two, you have to take it out. You don't put it inside because this is, if it is inside, then it will make the thing more complicated. Like that. Then negative 1. Okay, so if negative 1, that means this one will become ln later, isn't it? But for this one to become ln, integrate, then here what must we have? Okay, that means you have to differentiate the bracket here. Is it you must have negative 3? That's why we have this, something like this, negative 3, and then you divide by 1 over negative 3. So this one you divide, you get negative 2 over 3, and then the negative 1 can become ln because of the presence of this. With this, then you can change to ln. Without this, you cannot change. That is the technique of integration. Then after that, you simplify, you get this. Okay. Okay, next you come to this. Here also we can write it like this. Let's say I can write it e to x, and then this is 3 plus e to x, and then negative 1. Again, this is negative 1. Integration, you can change this one into ln, but with the condition that here you must have something else. That means you differentiate this. It's 2e to x. That means you must add a 2 divided by 2. This is what you get. Okay? Then with the presence of this, now you can change this one into ln. That's why you have half ln of this, and then you get this. Actually here you don't have to use modulus. You can use bracket. Why? Because this is always positive. This is always positive. Plus 3 is even more positive. And then plus c is because of the plus 0 here. Okay? And then here you want to integrate this. The 3, you take it out. Okay? 3, always take it out, the constant, you don't leave it there. Then x negative 1, 1 plus ln x, and then negative 1 dx. So you see here, the negative 1, I can change it into ln. Okay? Ln and then the whole bracket. But this here, the bracket, you must differentiate. Is it when you differentiate it, you get x negative 1? You don't have to add anything. It's already complete. This is already the condition. So you don't have to add anything. So now I can change this one into ln. So the answer will be 3 and then ln the whole bracket. The whole bracket is 1 plus ln x, and then that is the modulus. So that's how we integrate the ln. Okay?